In 2009, an HIV vaccine trial made headlines because the study showed some potentially promising results. In that trial, about 8,000 people were randomized to receive an experimental HIV vaccine, and the same number were randomized to receive a placebo vaccine. At the end of the trial, 51 people in the vaccine group had contracted an HIV infection versus 74 in the placebo group. How do we interpret the results of this study? Given these numbers, do you think that the experimental vaccine actually had any effect? This is a hard question to answer. Clearly, if there had been 60 infections in the vaccine group versus 65 in the placebo group, we would all chalk this minor difference up to chance and conclude that the vaccine was worthless. Similarly, if there had been 5 infections in the vaccine group versus 120 in the placebo group, this would be a landmark moment in the history of medicine because it would be clear that the vaccine worked. But with an imbalance of 51 to 74, we can't simply rely on intuition to draw conclusions. This is where we need the tools of statistics. Let's make an analogy. Imagine that the vaccine doesn't work at all. In other words, imagine that the chance of an infection occurring in the placebo group is identical to the chance of an infection occurring in the vaccine group. If this is true, the trial's results are analogous to flipping a coin 125 times and coming out with 51 heads and 74 tails. Can an imbalance this big arise by chance? Is it probable or improbable? To answer this question, I could write out some equations, or write out a computer algorithm, or I could just make my TA flip coins for a long time. I've asked my TA to flip a coin 125 times, tally up the number of heads, and then repeat that experiment many times. After a lot of coin flipping, we discover that when you flip a fair coin 125 times, you usually get between 57 and 68 heads. But about 4% of the time, you get 51 heads or fewer, or an equally imbalanced outcome of 51 or fewer tails. So, if the vaccine was completely ineffective, we would have about a 4% chance of getting a 51 to 74 imbalance, or an even bigger imbalance in the two study groups. It's not terribly likely, but it could happen. This 4% is what we call a p-value. The p-value provides one piece of information that can help guide our decision-making in medicine. It's a limited piece of information, however, and you'll hear a lot about its drawbacks as well as its uses in this class. If you want to learn more about this particular study and how to apply statistical reasoning to real examples in medicine, stay tuned for this course.